Okay, hi, this is John Orchard. Do you have me on the screen now? Hello?
Yep. Oh, yes, we do.
Okay. Thanks. This is John Orchard. I'm with the Spent Fuel and Waste Disposition Group in Las Vegas, Nevada. And on the line with me, I think, is Peter Swift from Sandia National Lab. He's going to help me answer any tough technical questions. The DOE, Office of Nuclear Energy, the mission, I think most of you are aware of that. Our spent fuel and waste disposition mission is to identify alternatives and conduct scientific research and technology development to enable storage, transportation, and disposal of spent nuclear fuel and waste generated by existing and future nuclear fuel cycles. Let's see what's happened here. There we go. Participants with us in this program are PNL, Savannah River, Los Alamos, Sandia, Argonne, Lawrence Livermore, Oak Ridge, Idaho, and Berkeley. The grand challenge for the spent fuel and waste campaign is to provide a sound technical basis for the safety and security of long-term storage, transportation, disposal of used nuclear fuel and waste from the nuclear energy enterprise. We have two sort of main functions. We got storage and transportation function and the disposal function. They're sort of, I think of them as the near term and the long term issues. There's some overlap in storage and transportation. Our mission, our purpose is to develop a technical basis to demonstrate used fuel integrity for extended storage periods. And these storage periods are somewhat undefined, but might go out to a couple hundred years. We want to develop a technical basis for fuel retrievability and transportation after this extended storage. We know what the condition of the fuel is at the time we put them into storage. We are looking, investigating to assure ourselves what the condition of the fuel is after this extended storage. And we're also investigating the transportation of high burn-up fuel. So far, we've got experience with normal, low burn-up fuel. Reactors are going more and more to longer times in the reactor, and we're getting high burn-up fuel, and we're looking at what the differences might be for storage and transportation, in particular, of high burn-up fuel. In the area of disposal, which is the long term, we want to provide a sound technical basis for assurance that the U.S. has multiple viable disposal options available when the national policy is ready. We haven't quite settled on our national policy, and so we're looking at alternatives. We want to identify research generic sources of uncertainty that challenge the viability of disposal concepts. There are a number of alternative disposal scenarios, and we're looking for generic uncertainties. We want to increase the confidence in robustness of generic disposal concepts to reduce the impact of site-specific complexity, which is to say, when we do come up with a national policy, we want to be on the ground running. We want to develop the science and engineering tools required to address the needs of these above issues. Let's see what we do here. Okay. Our two work scopes, we got FC 4.1, FC 4.2. FC 4.1 addresses the disposal issue. And some background to that is we have we are planning to have a repository. This is a generic or a typical repository. Shows basically it'll be a deep geologic repository. we're looking at alternative geologies for these. We're looking at tuff, salt, clay, and in crystalline material. A lot of the issues are similar. When we get into the actual disposal, we're looking at primarily looking at the barriers for the waste isolation. The components there are the actual waste form, which is what we're disposing of. The waste form can be spent nuclear fuel, or it can be high-level waste, or in some cases we've got greater than Class C waste in there. And the spent nuclear fuel, in our case, can be either commercial spent fuel or what we call defense spent fuel. Around the waste form is the engineered barrier. And the engineered barrier, the issues, the concern there are we looking for long-term corrosion resistance, and we're looking at multiple barriers. And then around that is what we call the geosphere, or the natural barriers, and we're looking at basically the migration of radionuclides through the natural barriers. On the storage and transportation system, the issues there are we have the, in particular, we're looking at the commercial fuel storage and transportation. And here we have a typical commercial fuel bundle. The fuel bundles are, of course, removed from the reactors, stored in pools for a certain length of time, and then put into storage canisters, which are then put into, set out in the field in storage overpacks, or casks, which look like this, and they're stored in the field in ISFCs, which are independent spent fuel storage installations. And one of the issues that we've looked at in the past is monitoring systems for these storage casks in these ISFCs. So this year, we're not going to have any IRP proposals or scopes of work we have in the past, but this year we're going to just go to R&D proposals, and we're looking at we've got 2 R&D proposals. They're going to be programs supporting R&D grants, university-led, with a budget up to $800,000 and up to 3 years. We have FC1 or FC 4.1, which is disposal repository, and we're addressing or looking at the what I call the chemical dynamics and the waste isolation barriers, the corrosion of the engineering barriers, the valence changes, and transportation of the radionuclides through the barriers, the engineering and the natural barriers, and into the geosphere. And then we have the second topic, which is FC 4.2, storage and transportation. And there we're looking at proposals for studying the repair and mitigation of postulated cracks in the SNF storage canisters. We have a concern that, especially in the heat-affected zone around the fabrication welds for the canisters, that there may be stresses built up that cause cracking, especially in the presence of chlorine. So we've got, we're looking at a chlorine-induced stress corrosion cracking, and we have some programs looking at inspecting and identifying the initiation pits and cracks. And this year we want to focus on looking at repair methods. And these topics are described more fully in the actual work scopes that I think you've been supplied with. And so I wasn't going to read all of them, I just gave you a background of it. But based on that, does anybody have any questions, I guess? Is anybody there?
Yes, we are going to unmute Peter Swift here. So just give us a moment or so to do that. Peter, are you there?
Yes, I'm here. Can you hear me?
Okay. Yep, we can hear you.
Great. Thank you.
All right, we'll start with some questions. Are models for the transport of fission gases out of a repository of interest here?
I would say yes, but Peter, do you want to answer that?
Yeah, it's not tremendously a high priority. If you look at what's been done in the past with fission gases, the short-lived fission gases are not going to contribute to releases from a repository over geologic time. The gas phase of probably of greatest interest would be actually carbon-14 and radon, and because both those do persist over geologic time. They're not fission gases, but look, it's not a tremendously high priority, but I'd be curious to see what was out there.
Is FC-4 interested in problems of aging and degradation of cement-based isolation barriers in applications to deep borehole disposal of nuclear waste?
John, this is Peter. Do you want me to take that?
Yeah, you probably can, sure, yes.
Yeah. Specifically, proposals related to deep borehole disposal are not included in this year's call.
For FC 4.2, are you more interested in the repair or preventative/mitigation aspects?
Pete?
Yeah, this is Peter. I'll take that one also. The repair, I think in the way you phrased the question would be the answer. If cracks already exist, what can be done as opposed to preventing their occurrence?
Yeah, I think the mitigation aspect was twofold. One was look at during the fabrication process is looking at mitigation for stress relieving, which is probably more of a mechanical issue or mechanical issue, engineering issue. But we're also looking somewhat at mitigation of the repair weld, if it is a weld, so that it doesn't. We're sort of looking at low temperature repair techniques that might not require a mitigation or much stress relieving, or if they do, how we would do the stress relieving.
And this is Peter. I would encourage anyone working on that, on the FC 4.2, to be familiar with the environment of the storage system, the geometry, the radiation field, the temperature field, because those will be relevant to what can actually be done.
Are models for pore scale coupling of heat and mass transport in the geosphere of interest here?
Peter again?
Yes.
Is hydrological modeling perhaps coupled with experimental work of interest, even as a conceptual model since no final site has been selected?
Yes.
Are there any studies addressing the weld failure systematically with and without exposure to postulate failure modes and ultimately come up with advanced joining techniques?
Can you read that again?
Are there any studies addressing the weld failures systematically with or without exposure to postulate failure modes and ultimately come up with advanced joining techniques?
I think if that's a question, would such a study be a plausible proposal? Is that how I should read that?
We can ask for clarification and move on to the next question.
Okay.
It sounds to me like an intriguing concept, but it doesn't offhand sound like it falls under the scope of 4.2. But yeah, if you get clarification, we might find out how it does.
Yeah, on to the next question. Does FC 4.2 include qualifying state-of-the-art sensing systems for storage canisters?
I would encourage potential proposers to be familiar with the awards in that area in past years. Basically, the short answer is no to that question, but if there is something there that has not been covered in the past, then it might be of interest.
Is crack initiation and crack growth study of interest?
The answer is going to be pretty much the same as the previous question. There have been previous calls in that area.
Is novel concrete materials for dry casks being considered?
Not in this call.
I think the answer is similar. We've looked at it in the past, and we're not looking at it this year. Good.
Do any repository geology types take precedence?
No.
For FC 4.2, does no spark source preclude the use of arc welding? Also, is it expected that the repair will be done in field?
I can't answer the first half of that. If the proposer has a way to make that work, we should hear about it. The second one, the answer is yes. As in the deployed location.
Are studies about repair and mitigation coupled with crack initiation and crack growth of interest?
Please read it again.
Are studies on repair and mitigation coupled with crack initiation and crack growth of interest?
I think that's a yes. John?
Well, I think the focus is on the repair and mitigation, but if there's an aspect of the initiation and the growth that would affect the repair and mitigation, like if your repair and mitigation approach changes as the crack initiates or grows, then it would be of great interest. For instance, if you study the initiation and can mitigate that so it doesn't grow, then that would be of great interest, I would say. Yes.
For FC 4.1, can you provide more detail about what is meant by chemical dynamics?
This is Peter. I would, on that one, I would refer to the actual text of the call, which is only available in draft form now, but it's intended in the view graph to be a broad phrase that covers the topics that are described in more detail in the call.
For FC 4.2, are there specific stainless alloys of interest for repair and mitigation since several alloys have been used historically? If so, Which are of greatest interest?
John, do you want to answer that one? I'll take it if you don't.
Well, we have a couple of different materials there, but yeah, if you know in more detail, yeah, go ahead.
Yeah, I would just say that the alloys of greatest interest are those that are actually in the largest use today, that are deployed in the field, and that have the greatest propensity for stress corrosion cracking.
Is disposal in environments like Yucca Mountain of interest?
An environment like Yucca Mountain would be of interest. Yucca Mountain itself is not a topic. And I can add to that to note that the DOE concluded in 2008 that additional research was not needed on Yucca Mountain.
If not FC-4, which program is the most appropriate for isolation barriers for deep borehole? Or is deep borehole disposal not being considered at all this year?
It's not a topic in the NEUP calls anywhere that I'm aware of.
What is the general thickness of the canister wall? Is the repair preferred to be applied when the canister is actually in service?
The first half of that is basically that it requires the proposal author be familiar with the types of canister that are in use today. The second part is, yes, the technique is expected to be deployable in the field for in-service canisters.
For FC 4.1, are heat and radiation impacted minerals of interest for radionuclide retention?
Potentially, yes.
Does chemical dynamics and waste isolation barriers include effects of phase transformation on the barrier microstructure and radionuclide transport in cement-based materials?
Nah, not a high priority. I'll just give that as an answer. The point there is that relatively few disposal concepts rely on concrete or cement-based barriers for radionuclide migration. So in that regard, the answer is no.
For FC 4.1, is there any interest in repair of uncanistered spent nuclear fuel? For example, spent nuclear fuel in dual-purpose casks.
The word repair confused me there. Can you read it again for me?
Is there any interest in repair of uncanistered spent nuclear fuel, i.e. spent nuclear fuel in dual-purpose casks?
If you can seek clarification on that, that would be great. The word repair didn't quite make sense. It might be a typo for something else. If it meant, the question was, are we interested in potential concepts for disposal of spent nuclear fuel without further treatment, i.e. in dual-purpose canisters? And the answer is yes.
So the clarification is the repair of a dual-purpose cask.
If the idea is,
I'd have to say yes.
Yeah, yes, but I'm still not quite sure where he's going with that, or she. But dual-purpose canisters as a disposal concept is worthy of further consideration, yes.
But I don't think in these calls we're looking for that aspect of it. However, most of the fuel now is stored in dual purpose canisters. And those are the ones that we're mostly concerned about the crack initiation and growth in, and therefore most interested in repair technique.
Yeah.
Right?
John, let me add to that. I would encourage people writing to 4.1 to be familiar with the disposal concept that their proposal might be relevant to.
Okay.
And if, for example, one were to propose disposing of dual-purpose canisters, there would almost certainly be a disposal overpack placed over them, and you wouldn't be relying on the canister itself as a primary barrier over geologic time. Just a thought. I mean, there are very few concepts out there for that, but proposal writers should be familiar with how what they're proposing relates to a larger disposal system concept.
Okay. If the question was addressed to SC 4.1, I agree that it doesn't really apply. I was thinking if it applied to 4.2, then it would apply. Would that make sense?
The next question is focusing on one aspect of the barriers for waste isolation preferred, or is a holistic evaluation of both engineered and geologic barriers together more desirable?
I think in our call definition, we've got 11 different components there, looking at each of the issues independently rather than holistically. But nothing would prevent. I don't think anything would prevent a holistic approach to it.
I would suggest that a holistic proposal might be a very ambitious proposal.
Right.
We certainly expect to see component level proposals. I wouldn't disqualify a holistic one.
Is vitrification of nuclear waste through fluorophosphate glass, or borosilicate glass of interest in this call?
I would suggest that they look at the waste form. There's a FC call specific to waste form. I would suggest they look there. I think we'd probably get a better hearing there.
Yep, that presentation is tomorrow morning at 10 a.m. Eastern Time. Are all repositories being designed to be recovered? Are all repositories being designed to be recovered for future use as new reactor fuel? Do all barriers allow reopening at reasonable cost and no collapse like in salt mines?
The answer to that is it's no, but also the question is outside the scope of the call. It's an interesting question, worthy of a discussion somewhere else, but it's not particularly relevant to the call.
Are there any used fuel disposition topics for waste reuse rather than just storage?
No.
Are 4.1 and 4.2 the same priority from a funding perspective?
Yes.
For FC 4.2, are the used nuclear fuel storage canisters assumed to be directly disposed?
No. For 4.2, the answer is no. The concern there is about their performance during interim storage.
How many awards are expected in FC 4.2?
I think you can answer that as good as we can.
Yeah, that depends on appropriations and available funds. We can't answer that.
Does FC4 cover how to get access to used nuclear fuel? I believe this is in reference to an industrial or a small startup getting access to a facility with used nuclear fuel.
Not directly.
I think the answer is no. I'm not sure what the question is getting at. Are they proposing to do tests on fuel that somehow the DOE provides to them? I'm not sure quite where the question was going.
What is the correct forum for used fuel reuse as new fuel?
It stumped me. I'm not familiar with, then John, you can take it too, but I'm not familiar with the rest of the call in enough detail to know if there is a place where that would apply.
Right, it certainly doesn't apply here, but outside it, FC4, I don't know.
Okay, we have run out of time for questions. We need to move on to our next presentation. We will forward any questions that did go unanswered to John and to Peter to provide email responses to. So thank you, Peter. Thank you, John.
Thanks. Okay, thanks, Drew.